the four basic concepts of mathematics and elementary logic. Our theme is discussing the relevance and importance of the basic concept of mathematics. Our objectives are to figure out what is set, relation, function, binary operation, and elementary logic. To appreciate the usefulness of the four basic concepts of mathematics and elementary logic. To enjoy mathematics and develop patience and persistence when analyzing and solving problems. Set, relation, function, binary operation are tools help in carrying out logical and mathematical set operations on mathematical and other real-world entities. Sets help in distinguishing the groups of certain kind of objects, whereas operation, relation, and function are the ways we use to connect and work with sets. It is very important that we see mathematics and the calculation as part of our daily life. Providing opportunities to apply basic concepts and logic and daily activities will enhance our skills and motivate us to progress in mathematics.
So good day everyone. So we have four basic concepts of mathematics. One of those is set. A set is a collection of well-defined objects that contains no duplicates, and the objects in the set is called elements of the set. So this notation uses specific elements belonging to a set. For example, the set C of counting numbers less than 4 has numbers 1, 2, 3 as the elements. We can say here that 1 is element of C, same for 2 and 3, but 4 is not the element of C because it says less than 4. So we have the three main ways to specify a set. So first is raster method. You have to enumerate the elements separated by a comma enclosed in a pair of bases. So for the example of this is this one. So number 2 is rule method. Phrase is used to describe all the elements in the set. Let's say for example, set V has the element of 2, 4, 6, 8, and 10. So if you're going to describe the set, we can say that all of the elements of set V are all even numbers. So the third one is recursive rules, means defining its members. So for example, the set of A of even numbers greater than 5. So we can say 6 is the element of A, and if X is the element of A, then X plus 3 is the element of A and nothing belongs to A. So that's the specific risk to specify a set. So the next one is equal sets, means two sets are equal and have the same elements. For example, this one, they are equal because they contain the same elements. Another example is this set. And this one, they are not equal because they don't contain the same elements. Next is the equivalent sets, means two sets have equivalent and has same numbers of elements. The example of this is this one. They are equivalent because they have the same numbers of elements.
Universal set is a set that contains all elements considered in a particular situation and denoted by U. Example is this one. So next is subset. It is defined as a portion, particularly in mathematics. So for example, A equals 7 and 9 is the subset of B equals 6, 9, and 7. Next is proper subset. So it is a subset that is not equal to the original set, otherwise it's improper subset. So example is the given 3, 5, and 7, which is the improper subset. Then the proper subsets are 5 and 7, 3 and 5, 3 and 7. Cardinality of the set, it is the number of distinct elements belonging to a finite set. It is also called the cardinal number. Next is the power set. It is a family of all subsets of a denoted A by the power of A. So the example is this one. Let's move on to operation on set. So first is union. It is an operation for set A and B in which a set is formed that consists of all the elements included in A or B or both denoted by U or as A union of B. For example is, if set A is equals to 1, 2, and 3 and set B equals to 2, 3, and 4, then a union of B equals 1, 2, 3, and 4. Next is intersection. It is the set containing all elements common to both A and B, denoted by upside down U or intersection. So example is if set A equals 1, 2, and 3 and set B equals 2, 3, and 4, then A intersection B is equal to 2 and 3. So next is complementation. It is an operation on a set that must be performed in reference to a universal set denoted by A. So for example, set U equals to 2, 4, 6, 8, 10, 12 and set A equals to 4, 6, 8, then the complement of set A is A equals to 2, 10, and 12.
Relations. A bond in daily life. People are related to each other in many ways, as parents and children, teachers and students, employers and employees, and many others. A relation is a rule that relates values from a set of values called domain to a second set of values called range. A relation is also a set of ordered pair x and y. X value is called domain, y value is called range. For example, we have here a set of ordered pairs 1 and 2, 2 and 4, 3 and 6, 4 and 8, 5 and 10. Remember, the domain is the set of all x values in the relations. Let's find where is domain and where is range. Looking back to the example, let's identify which are domain. Domains 1, 2, 3, 4, and 5. The range is the set of all y values in the relations. Going back to the example given earlier, range 2, 4, 6, 8, and 10. 1 and 2, 2 and 4, 3 and 6, 4 and 8, 5 and 10. This is what we call the relation.
Function. It is a role that pairs each element in one set called the domain with exactly one element from a second set called the range. This means that for each first coordinate, there is exactly one second coordinate, or for every first element of x, there corresponds unique second element y. Remember, a one-to-one correspondence and many-to-one correspondence are called function, while one-to-many correspondence is not. Example, the function can be represented using the following. First, table. The perimeter of a square is 4 times the length of its side. Second, ordered pairs. Then we have mapping. Therefore, this is a function. Then last is graphing. Using vertical line test, that is set of points in the plane, is the graph of a function if and only if no vertical line intersects the graph in more than one point. Below in figure A is not a function.
Binary operation. A binary operation on a set is a calculation involving two elements of a set to produce another element of the set. A Newmath binary operation using symbol star as defined to be A star B is equals 3A plus B, where A and B are the real numbers. Let's say for example, what is 4 star 3? The solution is 4 star 3 is equals to 3 times 4 plus B. When you multiply 3 and 4, the answer is 12. And when you add 12 and 3, the answer is 15. Sometimes a binary operation on a finite set, a set with a limited number of elements, is displayed in a table which shows how operation is to be performed. A binary operation star is defined on the set 1, 2, 3, and 4. An example of this is in the table. So to read the table, need the first value from the left hand column and the second from the top root, and the answer is the intersection point. For example, number 1. What is the 2 star 2? And the answer is 1. Number 2. Is 4 star 3 commutated? The answer is yes. 4 star 3 is equal to 3. And 3 star 4 is equal to 3.
Elementary logic, defined as the analysis of methods of reasoning. It is interested in the form than the argument. And it consists of drawing conclusion from given hypothesis. There are many premise indicators that commonly used, such as there, for that indicates a sequence that comes from before. One of the example of elementary logic is formal logic. It is used deductive reasoning and the premise must be true. You need to follow the premises to reach the formal conclusion. So, example, premise 1, bicycle have 2 wheels. Premise 2, John is riding a bicycle. Conclusion, therefore, John is riding on 2 wheels. So the premises are true, so is the conclusion. And the next example is the symbolic logic deals with how symbols relate to each other. It assigns symbols to verbal reasoning in order to be able to check the veracity of statement to a mathematical process. Example, proposition A, if all mammals feed their babies milk from the mother. Proposition B, if all cats feed their babies mother's milk. Proposition C, all cats are mammals. So, the symbol caret means and, while the arrow symbol pointing to the right means implies, so the mathematical conclusion drawn like this. And read as A and B implies C.